All right, I'm going to take the screenshot here. Ready? Everybody wave. Okay, cool. Well, I'm going to hand it over to Tyler, and I'll let him introduce himself and tell us about what his talk is going to be about. But I'll just say that he is our honored special guest coming all the way to us from California. Are you actually in the Bay Area, Tyler?
I'm in Napa.
Napa, okay. And so he's he's a developer at a software engineer at Facebook. Now it's called Meta, I guess. But awesome. He's also somebody who's been learning about artificial intelligence for years. And I think he even taught himself a lot of this, and he's now an expert. And so if you follow him on social media, he has a ton of really interesting insights about artificial intelligence and other things. So I highly encourage you to find him on LinkedIn and all his other places and follow him. But I'm really excited to hear what he has to say about software engineering tonight, and think about questions that you have that you might want to ask him, because I'm hoping that afterwards we can have some good conversation and discussion, both asking him or just in general talking. So with that, take it away, Tyler.
All right, thank you, Brenton. This is a very nice introduction. So we're going to talk about AI. We're not going to go through any code. We're just going to go through some general principles. So artificial intelligence is getting a computer to do something that normally requires human thought. For instance, a self-driving car. I would argue that even a computerized lawn sprinkler is artificial intelligence, because it normally requires human intelligence to water a lawn. And if you're getting a computer to do it instead, that could be called AI. So a lot of companies are saying, oh, we use AI to do this, we use AI to do that. AI is an incredibly broad term. So if somebody claims they're using AI, it's a good idea to probe deeper and say, oh, well, what kind of AI are you using? What data are you using? What algorithm are you using? If they can't answer those questions, they might be lying. Okay, so machine learning is a type of artificial intelligence. It's gained a lot of steam in recent years. Instead of programming a computer to do specific actions, you program the computer to learn on its own from information that you give it. Like, for instance, you could give it 1,000 pictures of cats and then teach the computer, hey, I want you to learn from these images what a cat is. So you can also say it's teaching computers by example. Like, for instance, you cannot program into a computer how to drive a car, right? Because there are just too many unknowns. There are too many variables there. So you have to give a computer some data, some videos of cars driving, or you have to train it on data, recordings of people driving, and then try and get it to learn on its own. So so we talked about AI. One type of AI is machine learning. And then one type of machine learning is deep learning. So we said machine learning is when you program a computer to learn on its own. The way that it learns on its own is called the algorithm, the special type of program that it uses to learn. There are tons and tons of algorithms, but the most important one recently is called deep learning, because it's a special algorithm that's based on how the human mind works. Instead of just like linear regression where it's drawing a line between points, deep learning tries to emulate the way your human mind works. How it does this is you've got neurons in your head. You've got a neuron here and then a synapse, which connects to another neuron, and then you have electrical signals, going back and forth. That's how your brain works. You've got a little neuron, sends a zap of electricity to another neuron, and then that shoots another zap of electricity, thousands, many, many times. I think humans have 86 billion neurons in their head, which is really cool. Cats have 1 billion. Dogs have 500 million, and elephants, surprisingly enough, have 200 billion neurons in their head, which is more than twice as many as we have, which is interesting. And it makes me wonder why elephants haven't built up their own civilization full of technology. So this is a real brain. This is an artificial brain. We have neurons, this is all computer code. We have a neuron, and instead of a synapse, we have something called a weight. and then we have another artificial neuron. And instead of shooting across a zap of electricity, like in your brain, we shoot across a number, right? A neuron shoots out a number, then another number, and another number. So this is all just kind of like math computations. We use a package called TensorFlow or another one called PyTorch. And then you just have all of these neurons connecting to each other. And again, this is not a physical system. This is all software doing all this math. And as you can imagine, doing all this math of connecting all these things thousands and millions of times, it takes a lot of processing power. So how is this practical? How do we go about doing this? So like I showed you, we've got this map of neurons all coming together. So let's just say that that's kind of like a brain. Like I said, the human brain has, 98 billion neurons. The most AI programs don't have nearly that many, but like a smaller one might have like a couple million. So you kind of train a neural network in a similar way to how the human mind works. Like you'll see, I don't know if you guys could see this over here, but you have input and you have a label, right? The first time you ever saw a cat, like when you were, 1 year old or something, you didn't just see a cat and be like, oh, that is an animal called a cat. Like somebody told you, hey, this is a cat. They have these picture books, and those picture books are popular for a reason. It's called data labeling. Like, you'll have a picture of a cat and it'll have the word cat under it. Those A is for alligator, B is for ball, those kinds of books. It's data labeling, but in humans. So then we have, an image of a snake, and then an image of the ugliest person in the world, and then person. So this is how the human brain works. And it's also how a software brain works. You give it an image and then you connect it to an output. And then you give it another image and you connect it to an output, and another one, and another one. And so over time, this brain adjusts. It adjusts all of the weights inside of it until it can accurately identify cats and snakes and persons. So then after you train it, after it's good enough that it's doing an accurate job, then you can sort of freeze it and say, okay, you can stop learning now. Then you put in a new image that it has not seen before, and you say, okay, what is this? And if you trained that brain well, it's going to give you a name, and sometimes it will even give you a probability. Like it'll say, I am like 85% sure that this is a cat. Okay, so now we're going to do image recognition. It's also called computer vision. So how does a computer mathematically know what this is? Because computers don't think in words like you and I do. They don't think in images. All they think in is numbers, 0 and 1, and that's it. So how can this picture of a cat be turned into something that means something to a computer? Every image is made up of pixels. See there, we zoomed in on his eye. And we see that this image is made up of a bunch of pixels, and this particular pixel is brown. And so it's got a red pixel intensity of 250, a green pixel intensity of 99, blue of 150. So every pixel is just those three values. And then we've got these darker ones, and that'll be like a lower pixel number for all three. Lighter ones will be lighter pixel numbers, higher numbers like around 255, etc. So then you just take this and you turn it into a number. It's just a series of numbers, 250, 90, 150, red, green, blue. And you don't do just that for just one pixel. You do that millions of times for every pixel in the image. And then you feed it into the computer and you say, hey, computer, this is a cat. So over many, many images, usually it takes around at least like 5,000 images to do a good job. You give the computer these massive bricks of information, and the computer looks at them mathematically and it figures out, okay, I'm seeing a pattern. There are similar number relationships in these images. And that is how a computer can tell what a cat is. It looks at an image and then it might draw, this is called a bounding box. It might draw a bounding box around the part of the image that contains a cat, because it notices that there is a pattern in the pixels, in the numbers of the pixels. Because again, like a computer understands nothing. A computer doesn't know that this is a dog. It just knows that this is a box of however many pixels with however much intensity in each channel. All right, so after we have trained a computer to know what a cat is, what if we reverse the algorithm? What if we say, okay, what is a cat? Then the computer will come up with something like this, and it looks horrifying, right? It's not a very good cat. So this is how computer generated images started out. They look horrible. So then there's a really, really smart guy named Ian Goodfellow came along, and he came up with something called a generative adversarial network. See, what he found is that he could generate maybe like 1,000 of these images, right? And maybe one of them would look good. And so he thought, well, okay, how can I get rid of those awful 1,000 ones? And how can I get one really good one every time? So he did this thing called a generative adversarial network, where there are two different brains. One is the artist and one is the critic. You see it here, it says, bro, I made a cat. And then the other one says, bro, that looks terrible. So each of these computers has been trained in advance to know what a cat looks like. What this one does is it creates images of cats, many, many images of cats, like hundreds, thousands. And each time this one tries to detect if it's an image of a cat. And as I said, there are probabilities. It'll give a low probability and say this does not look like a cat, it's really bad. And so this one keeps modifying its approach until it figures out how to create a cat that scores super high with this one, that the critic believes is a cat. So computers can work a lot faster than humans. So this only takes, a couple minutes of training to do. Whereas with a human artist could take years mastering the skill of creating a cat, but computers can do it very quickly. So this is actually a computer generated image of a cat. This cat has never existed. No humans were in the loop. Somebody just clicked a program and this cat was created. So this is the end of the process right here. You'll see one computer makes a cat and the other one says, hey, that's actually pretty good. So we can stop training. We're good at making cats now. So how many of you recognize this person? Good. And how many of you recognize this person? Neither one of these people have ever existed. These people were both created by a deep learning algorithm. Like I told you, you can generate cats, you can generate faces of people. As long as you've got a huge number of images, you can generate, fake copies of that kind of image. You'll notice that one dead giveaway is these little weird things right here, a little smudgy guy. Also, his nose is not aligned with his teeth. His nose is a little bit off. His eyebrows are a little bit weird too, his ears. And look at her nose, definitely not aligned with her teeth. The center of her teeth is over here, center of her nose is way over there. Also, it's not very good at backgrounds. So you'll see the background right here and it doesn't make any sense. Neither does his. So like when I first saw this in 2019, it blew me away. This is kind of what made me decide to get into AI, because I was like, I had no idea this was even possible. So if you want to do this yourself, if you want to generate a human face, you can go to thispersondoesnotexist.com, or there's a website called thisxdoesnotexist.com. And there are a bunch of websites exactly like this one that generate different things. Like there's this cat does not exist. This Airbnb rental does not exist. This car does not exist. And it's really fun to play with. Okay, so that is my last slide. Let's see how we're doing for time. Okay, so one thing that I would like to show you guys is there's something called Colab. And what it is it's a free online computer that you can use. It's a free cloud machine, and people use it for AI. So instead of having to go through the long process of installing TensorFlow on your computer, or installing PyTorch, and then maybe buying a GPU and hoping that things work, all you have to do is just go to colab.research.google.com, and it's already set up for you. They've got everything you need, and you can even send links to other people, and all they have to do is click on runtime and then run all. So this is a notebook that I made for you guys. It is a really cool thing where you can enter a text prompt and it will start creating an image based on that text prompt. So how they did this was they trained an AI model. It's called, I think, CLIP, C-L-I-P. So they had millions of images, I think 40 million images, and then they had 40 million captions for those images. So it wasn't just like a cat. It'd be like a cat running in a field with a mouse in its mouth. And then so they trained an AI on 40 million of those. And then just like I said, with the reversing and asking, hey, what is this? They did that. And so now you can enter any words you want, and you can create an image in that style. So I need anybody to give me a text prompt. Abdul, give me a text prompt. No? Okay, Mohammed Ahmed, give me a text prompt. What would you like me to make?
How about an alligator?
Okay, how about something a little more detailed than that, like an alligator doing what?
An alligator swimming in a pond or lake or something.
Okay, and anything else? Because
Can I have a red hat?
What was that?
Can I have a red hat?
Wearing a red hat. Yes. Okay, so I'm going to do runtime run all. This does take a while. It's probably going to take at least like a half hour before this gets done, because it's pretty computer intensive. But hopefully it will be done before we are. And we'll probably be able to see it start running in a little bit. Okay, so do we have any questions on what I've been talking about so far?
I have one.
Yeah.
My question is about the GANs you were talking about, the
Yeah.
generated adversarial networks.
Yes.
And you have two brains.
Mhm.
And so my question is, when one of them generates what it thinks is the picture of a cat, how does the other one have a different idea of what a picture of a cat looks like? Like if they're both using the same training data, wouldn't they always agree? If one of them says this is a cat, the other one would say, oh yeah, definitely a cat, even if they look nothing like a cat.
Well, that is a brilliant question. I think the generative process is different from the classification process. So, well, I mean, even if you just think in humans, like I could, if I had 1,000 photos of cats, right? I could classify correctly every single time that those photos are cats. But creating an image of a cat, I would be terrible at. I can't draw a picture of a cat to save my life. So if you kind of think about it as two people, like Brenton, let's say you are an art critic, and I tell you, like, hey, Brenton, on my side, or as a side project, I want to start drawing cats. I send you my first image. You say, this is really bad. Try it again. And then I keep trying and I keep trying and I keep trying, thousands of times. Then I will eventually get really good at creating cats. Computers are a little bit different because they will not tell you what's good or what's bad. They will only give back a number, like a number between 0 and 1. So as long as the number is getting better, this is looking more and more like a cat, then the computer says, okay, we're doing fine. We're headed in the right direction. So I don't know if that answers your question, but that is a really, really good question. And I don't know the answer. It's a really good question.
So I have a question. Like, I know we're not like diving into code or anything like that, but with TensorFlow, is there like a database that you need to set up with these type of algorithms? Because, go ahead.
No, good question. So, well, if you're training it yourself, then yes. So like we talked about, let me go back here. So when you're training a model on this, yes, you have to have your own database. You have to have a data set of, thousands upon thousands of images. And it doesn't have to be a database. It could just be a folder, but you have to have a lot of images. Like, I think it's like something like 5,000 per category or something. If you're starting from scratch, like 5,000 images of cats, 5,000 images of snakes, 5,000 images of people, and they all have to be a little bit similar. So it's a really tough thing to do. And yes, you have to create your own data set, not necessarily a database. And then on your computer, you sort of just tell the computer where these images are located and what their labels are. They could be in different folders, and that'll be the label, like a folder full of cats, folder full of snakes, and then you tell it to train, and then it will pull in all those images and it will train.
Got you. And then, so the algorithm itself, though, like, does it not need access to that database, or I guess that data set, in order to be able to, I guess, crunch and learn things?
Well, okay, so that's a very good question. So when you are training the algorithm,
Mm-hmm.
you do need access to the data set.
Gotcha.
But after the algorithm is trained, then you can just take this same algorithm and you can copy and paste it. And you can email it to your buddy, right? So it's just called a pre-trained algorithm. And you email the weights of this algorithm. Remember, we talked about the numbers that are in the synapses. You email those numbers to a friend. You can copy it, you can zip it. Like, for instance, in this one, the one that we're doing with generative AI art,
Mm-hmm.
it's been pre-trained. Like, people spent, hundreds of millions of dollars training this particular algorithm. All I'm doing is just downloading it. So at this point, I do not have access to the data set that they used. It's 40 million images, so it's a lot of gigabytes. But I do have that fully trained model, and they give it away for free, which is awesome. They spent like $100 million training this model, and they just gave it away for free, which is amazing. So
yeah, and that's pretty interesting, because I'm thinking about it, and I'm trying to, I guess, put in my mind like how this, like, I guess I'm wondering what the internals of this algorithm look like, because you're saying like it's like different synapses, like one neuron communicating with another neuron, except in the computer world, it's just ones and zeros essentially being translated back and forth, or it's just a number being passed. And I'm trying to imagine, like, how does that algorithm work internally, that, like, where you don't actually need the data set, it has a set defined parameters that it can operate in, and it's able to somehow learn from that. That's interesting to me.
yeah, well, I mean, that is a very good question. I find that sometimes it helps to explain AI in terms of like how a person behaves.
Yeah.
AI is nowhere near human level, but sometimes it helps to explain it in terms of that. Like, for instance, let's say I'm learning arithmetic. I'm just learning, 1 + 2 + 3 + 4, etc. When I go, after I learn it using a textbook, I don't need that textbook anymore. I can throw it in the trash. And then the next time I go and I take a test, I still have all of the things that I learned, all of the lessons that I learned in my head, and I don't need access to the data that I learned on originally.
Yeah, and it basically, in our head, there's probably some pathway of neurons that allows us to be able to remember and just recognize certain problems and formulas. And in a way, that's how the algorithms operate.
Yeah, actually, what you just said reminded me of something. So computers see things differently from how we see them. And so some computers, the weird wonky cat that we saw, we obviously know that that's not a cat, but some computers would recognize that as a cat because it has all the features that a computer focuses on when it's looking for a cat.
Definitely dope.
Yeah, and there are some really cool ways to confuse computer vision too. Like, there's like this chart of how to evade facial detection by painting your face in certain places, and yeah, it's cool. Oh, also, okay, so this is something I think about a lot, but I probably shouldn't. Like, if you are ever in a science fiction situation where there's a killer robot hunting you, all you have to do is just be upside down. Like, if the robot sees your face as an upside down thing, it will not be able to recognize you. Because all face detection systems are trained on a face that's right side up, and so if you were upside down, there's nothing they can do. So I've thought about that. Like, if a killer robot comes in and starts blasting people, I would do a handstand on the wall if I'm capable of doing that.
That would be interesting. Or how about turning your face sideways? Is it too close?
Okay, I'm going to show you something right here.
Yeah, there you go. Yeah.
If you walk around like that, you'd be safe.
Mm-hmm.
I think maybe if you walk around like that, you'd be safe, but all the survivors would give you silly looks if you keep.
Yeah, for sure.
And I don't know which is worse, being killed by a robot or being in an awkward situation. So
whatever you do to survive,
Yeah, that's true.
Yeah.
So that makes me think of the zoom filters that exist. how do you know if, okay, so here, I think can everybody see I've got like sunglasses on now?
Mhm.
Like
Yes.
now this, I don't know how Zoom did this. Do you think that they are using artificial intelligence to find my head and track it? Or could this be done with traditional software?
No, definitely can't be done with traditional software. It has to be AI. So what they're doing is, let me see.
I was thinking it's like OpenCV has like image capturing things.
Okay, so this this is what they're doing. They are detecting facial key points. Let's see if I can. They're detecting facial key points, and how they do this is they take thousands, millions of images of a person's face, and they manually label them. They pay a bunch of people to label stuff like this is the bottom of the ear. You see, they made a mistake here. It looks like they didn't label the bottom of the ear correctly. They did it correctly on this side. And then they label this lip, this lip, this is the nose. And then so they train an AI. These are all of these particular points. And then the output of that model is, where the points are. So right now, what's going on with Brenton's face is at, probably 5 or 6 times per second, the computer is taking in a picture, running that picture through an AI, and then outputting all of these points. And then a programmer said, hey, so we've got these cool glasses, and I want to assign them to 2 points, maybe the center of the eye and the center of the eye. And then I want, as Brenton gets closer, I want the image to scale up. And then as it gets farther away, I want the image to get smaller. So that's how this works. It's not super fast. You'll notice that like when Brenton moves his head, there's a little bit of a lag, you see? So, but a lot of people are working on making these models smaller and faster. So I've done these myself. Like there's another one that detects body posture, and I made an AI air guitar. So I can like strum and like play guitar like without even holding a guitar. So yeah, there's so much cool stuff. And if you learn this type of AI, there are so many applications for it. And if you invent something with it, you are likely the first person ever to think of that because AI is so new. So it's just a really, really cool and exciting new field.
I have a follow-up question to Xavier's that is close to what that's also related to what you just said about AI being new. I was thinking about, say you trained your AI using copyrighted images, and to Xavier's point, once you're done with the training, that AI is no longer using the source data, and so it's not, the AI doesn't have the copyrighted images in it. However, it was trained on those, and so in a sense, it's kind of got it in its brain, and it could potentially generate results that are influenced by this copyrighted material. So I'm curious if if the laws have caught up and made, is it legal to use copyrighted material in your training data, or is it an open question legally?
Very good question. I think that question has not been resolved. So the first generative adversarial network was called StyleGAN. It's the one that makes human faces, right? So they used a particular public image data set that was scraped from Flickr. Flickr is, I don't know, it was like a social media site where people would upload their images. It was like pre-Instagram. And people got mad that their faces were included in this data set. So they asked for their faces to be, taken out of the data set, but by then it was too late. This thing had already been trained. As far as I know, you can't really sue an AI or a company that made an AI for including you in the data set, at least not yet. And also, if nobody knows, so.
We actually dealt with a problem like that at a company I worked at. We had an AI trained on airline seating information based on passengers that would book. We could try to detect and predict how many people would book by a certain time on the flight. And there were so many hoops we had to jump through because airlines did not want their data being used to train a model that would then be applied to another airline. And I don't know how our machine learning person did. They did something that made the airlines not care.
Here's what they did. They walked into a dark alley with a paper bag in their hand and said, "Hey, you got the data?" And they said, "Yeah, I got the money." And then they took a data stick and they walked off.
Probably.
I'm kidding. Well, I understand that completely because, if another airline has that data, it could give them a competitive advantage.
Mhm.
And right now, oh my gosh, this is terrible. So I read recently, 64% of Americans feel that they have a good understanding of artificial intelligence. In my experience, it's maybe like 2%. So a lot of people think that they know very, very much about AI, and they're very scared of it. And it does not surprise me that airlines would be like, no, don't take our data because you're going to use an AI that's going to give them superpowers and they're going to bankrupt us, So.
Yeah.
I think we actually did a kind of the same way, Harrison. Like we dealt with this too with the company because Crunchbase doing kind of like having a lot of data and doing analytics and trying to do kind of like predictive stuff. That's, I guess it's kind of fun seeing the parallels between using just all the data point like financial information of a company to try to train a model to like predict when a company is going to get new funding or something like that.
That is really interesting.
And we use third parties for the data, and I'm like, it might be kind of different because we're upfront about it, but it's one of those where like we are training the model off of it, but then when we stop paying for like that subscription, it's like, okay, you have to get rid of all our data. We say, okay, we'll get rid of all your data, but we have trained, but like whatever we've kind of trained off of it, we still get to keep. It's kind of just like one data point, and I don't know what they worked out, but it's like maybe things are kind of going.
Yeah, what you just said sounds really cool. It makes me think like, hey, have you ever called a startup and said, hey, you guys are about to get funding? And they're like, what are you talking about? And then the next call is like, hey, we just funded you. Like predict before a startup knows. Mohammed, was it you who recommended the prompt?
Recommended what?
Recommended the prompt, the alligator in swimming in a pond.
No.
Okay.
That was me.
Okay. So sometimes this machine takes things a little bit too literal. So it is an alligator swimming in a pond, and it is in a red hat. You see, the alligator is inside of a red hat, which is not what we wanted. We wanted an alligator wearing a red hat, but we didn't say that. We put an alligator swimming in, actually wearing a red hat. Okay. Well, maybe it's saying the pond is wearing a red hat. I'm not really sure. This is very confusing, but sometimes it takes things too literal, or it interprets your words in a way that you would not interpret them. It's usually just really surprising, but it's coming out. So I think it's about like halfway done now.
Yeah, it looks like a platypus to me.
Yeah, we'll see. We'll see how it goes.
Yeah.
So what is this process we're seeing? Because it started out really blurry, and it's like I saw, okay, well, there was some red, so I thought there must be a red hat there, but it seems like it almost seems like it's just making it less blurry. So did it have an idea of the general structure at the beginning and it's just honing in on the details, or what is it doing each iteration here?
I don't know. I am not sure. Yeah, I'm sorry.
Is this going through a GAN?
Okay, so kind of. It's a little bit different from a GAN. It's called a VQ GAN. Shoot, this is hard to explain. Okay, so it does have two different neural networks, but they kind of do a different thing. It's called a bottleneck, where you've got two different neural networks and then they slim down to one little tiny bridge in the center. It's like an hourglass turned on its side. So on the one side you have your image, and on the other side you have your image. So what this AI does is it takes an image and it shrinks it down into the tiniest bit of information possible, and then it blows it back up. So these two neural networks learn how to compress an image and how to blow it back up. But it's not even compression, because it's way too little information to possibly get an image out. But both sides of these neural networks learn what an image is. So then you delete this first half, and then you put in like a word. or something. You say, cat, and then this side blows it up into a larger image. Like it could be of a cat or of a caption or things like that. So I'm not sure how to explain it further than that. It's a lot of really cool stuff. There's a program that it came from. Okay, so OpenAI is one of the most creative companies in the world for doing AI. There are like maybe 5 companies that are just really, really killing it. And OpenAI is one of them. They made this thing called DALL-E, which is you just enter a text prompt and it'll create stuff like this. Like they said, an armchair in the shape of an avocado, and it made these, which is pretty incredible. I've never seen results like this good for my stuff, for my experiments, but they can do some pretty cool stuff. And then after that, some other people started coming out with similar stuff, and this is one of the things you can do. There's an app called Dream by Wombo, and that's like this, but it's much faster. Let's try Wombo Dream. Here we are. Start creating. There we are. Okay, so I'm just gonna, this one's kind of turned out weird. So I'm gonna do this one instead. An alligator swimming in a pond wearing a red hat. And then we're gonna see swimming in a pond wearing a red hat. And you can do it in a lot of different styles. I'm just gonna do HD, see if that looks realistic. See, this is a similar program in that it creates art from a prompt. But this one has been sort of commercialized. Like we were talking about, JavaScript versus Python. This is what it looks like on the back end, all of the AI powerful stuff. And this is, a JavaScript interface. Oh, there we are. Well, there's an alligator, kind of, and a red hat. So not perfect, but you can kind of see what it's going for. All right. Any other questions?
Might have one. Oh, okay. Wasn't sure somebody else came off mute. I was kind of curious with some of the, you mentioned some of the like facial recognitions, and when it comes to like real life where it's like 3D, or you might be getting different angles or things like, is it kind of just like adding another dimension to some of this same stuff of like, well, now instead of just getting a picture of the front of somebody's face, we get like different angles? Or is it kind of like it's a whole, is it a whole different ball game when it comes to like going in 3D kind of stuff?
A very good question. It is a completely different ballgame. In fact, there is there's TensorFlow and PyTorch are the 2 main AI libraries, and they can do a lot of really cool stuff, but they cannot do 3D. So there is a new library called PyTorch 3D, and it is specifically for generating 3D objects. So like, let's say like Photoshop versus, a 3D design program. Those are 2 very, very different ways of thinking. And so it's the same for AI. You have to have special framework set up. Surprisingly enough, as much work as there has been done on images, like image classification and seeing things, there has not been nearly enough work done on 3D objects. I think it's because it's a lot of information and not a lot of people understand it, and 3D objects are hard to work with.
I have a lot of questions, so I'm going to give other people a chance to ask a question before I ask another one, but I do have a question. I want someone else to ask a question first, though.
Everybody
hey, it's my dad. You see the other Brenton Strine down there? That's my dad.
Oh, great.
Hi, Dad.
Hi, Brenton's dad. Oh, you're on mute.
I'm late. I had to pick up my grandson from his tutoring class. Sorry. Hi, everybody. I'll just disappear again.
Right. Any other questions?
Tyler, I'm sorry.
Yes.
Go ahead.
Oh, how those deep fake videos work?
Really good question. Okay, so deep fake videos work by, where was that? Face. Okay, so face key point detection. We're going to look at that again. Okay, so how this works is, so let's pretend like I want to take over ref code. And so I swap Brenton's face for mine. So what I do is I find a good photo of Brenton and then I run it through this algorithm, right? And it identifies all of the key points on his face. And then, so you know how Brenton's glasses, the black glasses were following his face? What I do is I do the same thing, except instead of black glasses, I put Brenton's entire face. Yeah, see, Brenton's got the black glasses right now. So instead of those black glasses focusing on my eyes, I take a photo of Brenton's entire face and then I align it to these key points on my face. So when my mouth opens, the image, its mouth opens, my nose, my ears, everything. So everything is aligned. It's just a photo of Brenton over my face and aligned to my movements.
I've seen a few where that is able even to mimic the expressions. So they'll be using like a data set from the person, like training a machine learning algorithm,
Mhm.
and then like putting on top of the original video.
Yes, you can do that with a video too. It's probably easier to do with a video because then you can, do it in advance and you don't have to do it in real time.
Okay, cool. Thank you.
You're welcome.
Tariko had a question, I think.
Yeah, my question was like, I think like more neurons means like more functionality. Yeah. So for example, our brain, like there are a lot of neurons, so they do some calculations. Yeah. And like the same way in CPU, there are a lot of transistors and they do some stuff. But like in AI, is it like a lot of functions inside function and inside function? Is that how they write code?
Good question. Generally, I mean that I'm gonna say yes, because I mean you could create an AI that has billions and billions of parameters that is not good, but the best AIs so far have that many parameters. They have billions. I think Microsoft came out with one that was 175 billion parameters, and it's like a language model. Oh, another really fun one to show you guys would be GPT. We focus mainly on images, but there's a program called GPT, and it, just like this generates images, it generates text. So you can say, give me a really nice thing to say to my mother on her birthday, and then it'll spit out human-like text. It'll say, mother, you're my favorite mother, you've always been there for me, or something like that. So computers can generate text just as easily as images. And one of the biggest models ever is, a language model.
Okay, thank you.
Okay.
Okay, I have to ask my question. I saw, this was actually a YouTube video, but this guy generated a racetrack and then he made thousands of little race cars that would drive randomly. And then he had some way to evaluate the ones that got the farthest on the right racetrack. And then he eliminated them, or I should say he generated new ones using the ones that were the most successful. And over time, they were able to like complete the track. And I'm pretty sure there were no neural networks involved in this. So it seemed like it was kind of like AI in that sense, but it wasn't a neural network. So what was that?
That's called genetic algorithms. It's kind of like natural selection, where the survival of the fittest. I've seen somebody play Mario that way. It's called like mar.io or something. So I'm not sure if it's neurons. It's like certain actions that die off as they're unsuccessful. And as the time goes on, if the action is successful, then it breeds with other actions to create more and more successful stuff. So I haven't heard a lot about genetic algorithms recently. It's more been about reinforcement learning, which is a little bit different. Reinforcement learning does involve a neural network that learns through actions and then receiving a reward rather than, killing off or breeding. It is a cool idea though. Any other questions?
Hi, this is Brenton's dad again. I don't know if you covered this because like I said, I'm late, but is there any way that a lens on a laptop can sneak or spy on you without your permission? And like my wife covers up on the smart TV at night because she doesn't want anybody looking at us. Is that possible?
Yes.
Whoa. So is she doing the right thing by taping the little lens?
She is.
How is that possible?
Well, okay, so I think it depends on the computer, but if you, like my computer has a light that lights up when the camera is in use. But if that light is not, directly connected to the camera hardware, it would be theoretically possible to just control the laptop and turn off the light, but still be using the camera. So, computers they try to be secure, but it is possible to hack into, anything. So, if it's connected to the internet, someone can probably get into it.
Oh, wow. All right,
Yep.
thanks.
So I try to close my laptops when I'm not using them. Or you can 3D print a cover that you can slide. So.
I use a little piece of painter's tape.
Oh, that works. Xavier says, invest in good network security systems. Yes. And tape your video camera.
Like maybe one more question.
Absolutely.
Yeah. For example, like when I say like more neurons, for example, on the CPU, there are a lot of neurons, billions of neurons, but they say most of them are used for caching. Yeah. So like, even like when you mention like elephant, they have like 2 billion something, yeah. And elephants, they are called like, they never forget. So like, is that the same way like in artificial neural network, they use caching in their code?
Oh, well, okay, so I'm not entirely sure what you mean by caching.
Caching means like saving data.
Oh.
So it's not like most neurons, it's not for calculations. It is just caching, so they remember things. There is some caching. Some neurons, they are used just for caching.
Well, okay, so CPUs don't really have neurons, they have transistors, which is a different thing. A neuron is like an artificial neuron. It's kind of like a software construct. It's just some math that a computer is doing. And as far as I understand, in a neural network, we kind of don't know which neurons are for what, right? They kind of learn on their own. For caching data, that's a really, really complicated question. So I think what you're asking is the neural network actually storing data within itself?
Yeah, within itself, yeah.
Okay, well, that's a good question. You don't want it to. And the reason why is you want a neural network to discover the underlying patterns. As in, like if you give it a database of 40 million faces, you don't want it to just recognize those 40 million faces. You want it to recognize every face. So it does store data, but it does not store the exact images. We're trying to get it to store the patterns. So we're trying to get it to store the fact that a face has 2 eyes and a nose and a mouth.
Okay, like so, like those patterns will they not be saved? Like all the patterns, maybe they will be saved like separately.
Yeah, the patterns get saved.
Okay.
So, yeah, I think this is similar to the question that I asked in regards to like, are these algorithms using database? I'm thinking back in like programming, how like you can create a class and that class has methods in it. And in those methods itself, whatever you define in there, you can reuse over and over. So I'm wondering if these AI network models, are they like saving functions, and in these functions, there's some, algorithm to identify a wide range of different things? Is, in a way, is that kind of what's happening?
Yeah, actually, an AI is a function. It's sort of, it's called approximating a function. So with a normal function, you have inputs, and then the function transforms it, right?
Mm-hmm.
With AI, you have an input and an output, and you're trying to figure out what the function is. So the entire AI is the function, and it learns what it is. It learns how to transform things depending on what your inputs and outputs are that you give it, like cat, and then, a picture of a cat, or the word dog and a picture of a dog. And then you show it these things over and over and over again. And then it learns to transform the word dog into an image of a dog, or vice versa.
I guess that process of learning is like, that's kind of what I would want to like dig into. Like what does learning look like from an AI's perspective? Is it like writing in a text file, some numbers in there for itself so that it knows that, hey, this number is associated with, I don't know, like this series of numbers is associated with what you may see in cats, right? Like I'm wondering how it goes about doing stuff like that underneath the hood.
That's a really good question. So, I mean, I can tell you from our perspective what's going on, but you said from an AI's perspective, that is super interesting to think about. Like, here's the story that I have inside my head. Like, you wake up, you don't know anything, you're in a world that's completely dark. All you see is a number way above you, and it's a very large number. It's in the thousands, and all you know is that you have to decrease it. You have to make it smaller. And you know that there are valves all around the room where you are. And so you begin frantically running around, turning those valves while looking up at that number. And then you find some valves that make the number go higher and some valves that make it go lower. And so by turning the valves and twisting them over and over and over again, you finally get that number to where it's super low, like 0.001. And then you black out and you lose consciousness. And so that's what life as an AI is like during the training process.
I'm like visualizing that. Yeah, that's I don't know, that's interesting. That's definitely something I would want to like dig into, like under the hood, to kind of, is it actually, have they made processes where you can visualize like what's happening with a neural network as it's learning something?
Ooh. First of all, that is an amazing idea. That is a really cool idea. There are, but they are super simple. Like it's just like a line, like it's getting more and more accurate. But
Yeah.
if you could visualize what's going on inside the neurons as they're learning, that is a super cool idea. I think that'd be amazing. I've seen a program where you can visualize like after an AI is trained, like what the neurons look like, and they're very pretty. But I've never seen one that does it in real time. That's a really cool idea.
Interesting. Yeah, I guess I'm curious to like there's an initial, like you have a file, and let's say this file is 10 kilobytes, right? And it contains an AI algorithm inside of it. After that AI goes through like 40,000 or 50,000 files, I'm wondering if that initial algorithm that gets updated to now include more stuff in order to match, what it's been trained against. Or is there something else that's like outputted to help it, be able to match up with all the inputs that it gets?
That is a really good question. So first of all, any deep learning model is probably going to be in the hundreds of megabytes.
Yeah, probably. Yeah.
But so just from memory, it seems to me that when I have trained an AI program multiple times, the output model was different numbers. you know, the output model was different sizes. Like I'll train it once and
Gotcha.
it'll be like 300 gigabytes, and then I'll train
Yeah.
another one and it'll be 315 or something. So
Oh, wow.
yeah,
Okay.
it seems to me that they do change quite a lot.
Sure. Okay. That's crazy.
Mm-hmm.
Have you ever written an AI, I guess, algorithm yourself?
Oh yeah, absolutely. I mean, like, okay, so this was a big turning point for me. I didn't understand AI. I didn't understand deep learning, and I wanted to, and I was very frustrated. And so what I did was I found a very easy Colab notebook, like the one we're on right now, except this one's not easy. I would go for a very simple one, and I typed it out. I had one window with the notebook and another window with my code editor, and I typed it out line by line, and that really helped me understand it. So that was the point where I felt like, oh, I understand this, because like an AI can be very, very simple. It's all it is layers of neurons, right? So it's kind of like a pancake stack. So you can have maybe, one or two layers on the pancake stack to do something really simple, or you can have hundreds of layers on the pancake stack to do something really complex, like this guy. Yeah. So as you talked about, you wanted to know what's going on mathematically inside of the AI. It's a lot of calculus, and it's using something called the chain rule. Yeah.
Gotcha.
So it's basically just messing with the weights or messing with the synapses and the numbers inside of the AI until the input is turned into what we want the output to be.
And you said you like copied the code inside of CodeLab and like line by line, and that allowed you to get a better understanding.
Yep.
I'm assuming because as you're copying it, you're kind of also tracing like, well, what does this method do? What does this function do? What does this variable mean?
Nope. I mean, well, I wasn't tracing back to functions. All I did is I literally just typed out all the code in that notebook, and it helped me understand it. And from then on, like, if I need to understand code, I type it out.
Okay, gotcha.
Because I mean, you can look at code and it's not going to make any sense to you. You can run it; it's not going to make any sense to you. But typing it out really, I don't know. It forces you to focus on it.
Yeah.
So would you also recommend some kind of online links so we can further explore and go through for our information and training purpose?
Yeah, absolutely. So there's a YouTube channel called Deep Lizard, and I like them a lot. Okay. They're very, very good at being super duper. Yeah, see, Deep Learning Fundamentals course intro. They are very, very simple. She's a super good teacher, and she's very good at keeping things, understandable. There are a lot of people who are not that way. There are a lot of people who, I don't even know, they just give you buckets of information and it never sinks in. It's really hard to learn. There are some teachers who I just really do not like because they just can't teach. But she is very, very good. There's another link on my LinkedIn. I don't remember what it was. Let me see. Somebody else who I know had posted this link to just an all-in-one, go to this site and you can learn everything. But I think it was in last week that I posted it. So let me see. Yeah, this is another one I generated using that same program that we're working with the alligator on. And this is another one, a spaceship.
That's amazing spaceship.
Right? I was so excited about that. Okay, so, here we are, machine learning with Python. Okay, so Free Code Camp is a great website. I did not learn from Free Code Camp, but the engineer who inspired me to do coding was the one who recommended this website to me, and it does look really good, like machine learning fundamentals, core learning algorithms. This looks like it's very thorough. So This is what I would recommend if you want to. I think this is much more serious, whereas Deep Lizard is more casual. So I would try Deep Lizard first and then come to this one. Okay. Any other questions?
Yeah, I have one if I could be so bold. This is kind of a
Be
future
bold.
question. Mental brain disorders, talking about neurons like Parkinson's, MS, Alzheimer's, dementia, etc. It would be interesting if there was research going toward trying to replicate the neurons, say in Parkinson's, that are killing off dopamine, like nanoparticles. You know how they have prosthetic arms that are controlled by nerves? If that could be done in the brain, do you think we're ever going to do that, or is anybody researching that?
That is, first of all, that is a really good question. I think 2 or 3 weeks ago, a brand new discovery came out. What these genius scientists did is, you know how I said with an AI, you've got your inputs and your outputs, right? So what they did is they put a single human brain neuron into a petri dish, and then they put some inputs into it and some outputs, and then they just kind of figured out that was their data. Their data was all of the inputs and all of the outputs. And then they tried to figure out what is the smallest artificial neural network that we can have that will learn the same way a human neuron learns. And they found it. They found, I think it's like, I don't remember, I think it's like 7,000 artificial neurons can emulate one human brain neuron. So if you have, if you have just like an electronic device that can run, these 1,000 artificial neurons, then it can emulate a real neuron. So I think your question, yes, I think the answer is yes. We don't have the technology right now, but I mean, after as of 2 weeks ago, I think that technology is coming.
Wow, that's awesome. Thank you.
Isn't it? I'm super excited about the future.
I'm going to email Elon and have him throw some money at that.
Great. Tell him I've got a proposition for him.
All right.
AI powered buckets. All right. Any other questions? Is there any other way I can help you guys?
Can we contact you after some?
Yeah, absolutely. Yeah, absolutely. If you wouldn't mind contacting me on LinkedIn, I'm the only person with this name. And yeah, just message me if you have any questions about coding or about careers. I'd be happy to help.
Okay, thank you.
Thank you.
Yeah, everybody's just hanging on your every word. Usually by the end, people are like dropping off, but I'll give people just a little bit more time. Do you have a few more minutes in case there's more questions?
Yeah, I got plenty.
Yeah, we'll extend it a little bit past 8. We're at 8:03. So if y'all have a few more questions or you want to keep it going, it seems like there's a lot of energy. So I don't want to cut it off if Tyler has a little bit more time.
Yeah. If you guys have any other questions, I'm all ears.
I saw Tariku unmuted for a second there.
Yeah, I think maybe one question, like, is there any website like you recommend us, like with what's called, with like key formulas? Yeah, for example, there are some matrices. Then, for example, one matrix, it can detect I, one matrix can detect no, something like that. So is there any website, that has, many, matrices so that we can try any of it? Like, is there any website?
Are you talking about like engineering features on your own, or what do you mean?
I mean, for example, I thought like on YouTube, there are some matrices. So you will multiply that matrix with an image, then it will give you like the eye. Then one matrix, it's like a node. So the formula is like on the matrix. So you just multiply that, so it will detect like this is node, this is here, something like that. So
yes.
Like, is there any website that can give like that information freely, so we can use those?
Well, okay, so let me show you. So the matrix that you're talking about, the computer learns the values in that matrix on its own. So it's not really something that you can just take out and say, this is my matrix for detecting people's faces now. The computer uses that matrix. Let me show you. I have a diagram of it. It is called a convolutional neural network. Okay. Uh-oh, is it not here? There it is. Okay. So as we said before, an image is a collection of pixels, right? Each one of these numbers is a pixel. So we have this thing called a filter, which is like the matrix that you're talking about. And this filter, it's kind of randomly initialized. It's random what these numbers are. And I think that's what you were talking about, the matrix with different numbers. So what this does is it slides over the image, you know, line by line, row by row. And then you multiply the pixels by the number in that image. And then you add them all up and it's, you know, whatever number. So that is how the computer learns the features. So you can't really like find this matrix and download it and then use this matrix by itself. It's a part of a larger program. So, I mean, you can download computer vision models and then run code to, you know, run an image through that. But a matrix like this or like this would not be useful.
Okay. Yeah, thank you.
Some of it, if I can't talk about it, like some of the AI stuff that I'm most excited about is like the prospect of, there's a guy named Ray Kurzweil, and he predicts all these things in the future that have actually happened. Like he predicted cell phones, he predicted self-driving cars, and he predicts that within the next 15 years, technology will be smarter than biology and people will no longer die. So I think that is a really cool technology prediction. Also, there are a lot of really cool AI things online that you can try. Like I said, this X does not exist. This is a website for generating whatever you want. Person, this person does not exist. This rental does not exist. That one's fun. You can also do, I think any type of AI you are interested in, you can search for a demo. Like let's try image classification demo. Let's see if we can find one online. Let's try this one. Allow. We want to allow that. All right. Okay. Well, that one didn't work. Oh, maybe that one. Okay. Well, a lot of times, if you're interested in one particular type of AI, you can find it online, and you can find demos for it and places to use it. So, any other questions?
Yes, I have, if you don't mind.
No problem. Yeah.
So remember you showed me the small piece of a hardware with you. So, so since my field is electronics and I'm looking this AI with respect to this hardware, so I know that my company, they are using some software and then they route the traces in that software. I mean, of course, this hardware contains some PCB, and inside the PCB, they route so many traces from point to point. And for example, if we have a 5,000 traces to route, say they do it manually. So I know that there are some companies which are working with some AI industry to automate it. So my question is, so for example, if I want to do this for my company, so how I'm going to do this? How to bring the AI in another software which is doing this kind of a routing kind of a things?
Okay, so very good question. Correct me if I'm not answering it correctly. There are two ways. One is called Edge, which is where you have the AI model on the device, and that's kind of a bulkier device. Like this you would not be able to do any substantial AI on this. You would need something like a Raspberry Pi, which is like that big, or maybe even a Jetson Nano, which is a little bit bigger. That's Edge if you want to put the AI on the device. Another thing that you can do is IoT. So what you would do is, for instance, let's say I have a Raspberry Pi, and it can detect when my cat is home, right? It uses a camera and it detects if my cat is home and it sends me a text. So I could have all of that on my Raspberry Pi, the model and everything on the Raspberry Pi. Another thing that I could do is I could just have a super tiny device like this one. I could just have a super tiny device, take a picture, and then send the picture to another computer. And that computer's bigger, stronger, beefier. And the computer does all of the AI work. And it looks at the image and says, is there a cat? And then it sends the information back, or it can send the information wherever I want it. So yeah, so that's the difference between IoT versus edge, is which computer is doing the processing. So I think it depends on how fast you need it to be done. Like if it's real time, then you're going to want some really expensive like edge hardware. But if it's like, you know, maybe once every 5 minutes, then, or even like once every 5 seconds, then you can use a smaller thing like this.
So and do we also need to have some kind of a library for this? Because I know that some electronics company, they are working with like NVIDIA. We know NVIDIA is giant in the graphic card. So they are actually working with the AI team, and they have some their patent libraries, which we don't know. So so do you think we need to also develop some library kind of a things for this if I want to initiate this?
I don't think you need to develop your own libraries. Well, again, it depends on your application, but most of the time the libraries are already written. All you have to do is just, you know, modify the code and put the libraries together. There's kind of a middle ground. It's called a Raspberry Pi Zero. It's not as powerful as, you know, the big Raspberry Pi, but it's a lot more powerful than this. So what I would do is I would maybe buy a couple of different hardware solutions, like search for Edge AI, maybe get a Jetson Nano, get a Raspberry Pi, and get like something Arduino or a Raspberry Pi, what was it called? Raspberry Pi Zero, and try them all and see which one you think is the best. Another solution is Amazon Web Services. You can take a picture and then send it via the internet to Amazon Web Services and then get back instantly, well, 5 seconds, in 5 seconds, a label that'll say, you know, there's a cat in this photo or something like that.
Okay, thank you so much.
Welcome.
I need to drop by actually, but I really enjoyed this wonderful session. I really appreciate your time.
Oh, thank you. I'm glad you enjoyed
it. Yeah, Tyler, thank you so much. I think we should probably end it there. Everybody, thank you so much for coming and attending and seeing what Tyler had to share. You know, I thought I really liked hearing that little thought before he logged off. Before we go, I wonder if everybody who wants to might unmute for a moment and just give a little shout out to Tyler, either a thank you or something you learned, something really quick that you just that you took away from tonight. Since we can't really have the same effect of like applause that we would if we were in person, I thought it might be nice for everybody who wants to unmute and just say a little something to Tyler to show some appreciation. And I'll start by saying, Tyler, I learned so much tonight. I've looked into AI in the past, and I knew a little bit before, but I gained a really deep insight. And you're one of those people, like you said, some teachers are not very good, but you're one of the teachers who is very good. And I appreciate the way you're able to take a very difficult concept and a very hard to explain concept and make it fun and understandable. So thank you.
Oh, well, thank you. Appreciate that, Brenton. Thank you.
Yes, thank you, Tyler. It's a
Yeah.
pleasure. And is there any way I can hear what was missed that I missed about an hour's worth?
Oh yeah, Brenton.
Yes, it's recorded. Yeah, and I'll post it on the website, and Dad, I'll send you a copy special.
All right. Thank you and good night.
Thank you. Thank you guys for listening. This was really fun for me too.
Yeah, thank you so much.
Yeah, Tyler, thank you so much. This was really dope. I definitely learned a lot.
Good.
And before I was hesitant in starting like TensorFlow, but the way you're able to break things down and like really explain it in a simple manner helps, because there are a lot of videos that make it very, very complicated. So
yes. So I would stay away from TensorFlow. I would focus on PyTorch instead.
Okay, gotcha.
It's easier to learn. It's more reliable.
Okay, fair enough.
Thank you, Tyler. Thank you for your time. And yeah, like he was saying, like Xavier was saying, I thought it was you had to like have a PhD in mathematics to know machine learning, but yeah, it was very cool.
I don't have a PhD. I never took an in-person class. Everything I know about AI, I learned through online classes. So
Okay, cool. Thank you so much.
thank you. Thank you for listening in. This was fun. All right, is that it? All right. All right, well, thank you for having me, Brenton. And maybe we can do this again sometime.
Yeah, it was great. Really, really thought this was great. I hope that everybody goes home and tries something with AI, and we'll have to have you back some other time to go more in depth. I think that you've sparked a lot of interest.
Cool. All right. Goodbye, you guys.
Okay.
All right, goodbye. Bye, everybody.
Bye. Yeah.
See you
Bye.
next week.
Bye.